All right, hey everybody, here is a quick little lesson about power. Power is the probability of rejecting the null hypothesis when it is in fact false. So, in other words, it's the probability of being correct when we reject the null hypothesis. It's the probability of making a correct decision when the null hypothesis is false. So we can also consider it this way. Power, because it's not making a type 2 error, that's what it's called when we reject the null correctly. So power could be called 1 minus the probability of making a type 2 error. And we could have the inverse of that as well. Now, to understand power, we're going to calculate it, but you almost certainly will not need to do this on the exam, but I'm going to show you how power can be calculated, because I think it will then help us understand, well, what affects power. So, without further ado, we are going to say that the parameter is 0.5, and we're going to test it as being greater than 0.5. But in reality, we happen to know this. Now, we almost always don't know this. In fact, you won't. Why would you be doing statistics with a sample if you did? But in order to talk about what power is, you have to know, or what the actual power is, you have to know the true parameter. So we're going to calculate this thing called power. To do so, the first thing we're going to do is say, what is the p hat for which we will reject the null hypothesis? So if the null hypothesis is 0.5, and our standard deviation would be 0.5, square root of 0.5 times 0.5 over 100, our alpha percentage is 5%. So what is the p hat going to be at a percentage of 5%, or what is the 95th percentile is another way to ask that. And so we can use inverse norm to calculate that. And so we would reject the null hypothesis for any values of p hat that are greater than 0.5822. Okay? We would reject the null hypothesis for anything greater than 0.5822. All right. Now that we've calculated that, given that p, the actual parameter, is actually 0.62, what is the probability that we will reject the null hypothesis? So in this case right here, we're now saying that the parameter is 0.62 and our p hat is 0.5822. Therefore, our standard deviation, square root of 0.62 times 0.38 over 100. And the area above 0.5822 is the power. That's because we actually know in this instance that this is the true parameter, and we will have rejected the null hypothesis anytime it's greater than this. We can then go calculate the probability. This is doing normal CDF. The probability that p hat is greater than 0.522 is 78.2%. Now, to see these things, it helps, well, that is the power, 78.2%. It helps to see these things on top of each other. So here's the original curve where we didn't know what the parameter was, but we had a p hat that was 0.5822, that was the 95th percentile, where the power is going to be, or where alpha is 0.05. And so we would reject any time it was greater than 0.5822. But since the true parameter is 0.62, for any sample that we were actually going to be taking, this yellow, this is everything to the right of this vertical line here where p hat is, that was the 0.7822. So you see how these things overlap. Okay? So the questions that you're most likely to be answered have to do with, well, what affects power? So we're going to talk about, in this case, what increases power. And then similarly, what would decrease power. But if we were to increase the alpha, let's think about what happens here if we increase this alpha. I'm getting these two overlaid again. And the yellow portion is the power, right? And if we increased alpha, what would change? Well, if it's currently our alpha is at 0.5, but if we change the alpha to 0.05 alpha, if we change it to 10%, then our line would move over. The line would move to the left. We have a 10 percentile or 90 percentile of the original curve. We would reject 10% of the time. And so this blue portion right here is what's added to the power. The power has increased by this much because alpha has increased. Okay? Another way to increase power is to increase the sample size. What happens when we increase sample size? Well, when we increase sample size, the variability will decrease, which means that this curve will get a little skinnier. And then therefore, with our alpha of 5%, well, that's going to be moved over to the left a little bit, which is going to increase the power. Because remember, this is all staying the same. Nothing changes. The parameter is the parameter. We are just increasing our sample size. I suppose, but our sample size, this would also increase and make it even greater, actually. So increase the alpha, increase the sample size. These are the two main ones. I'll put a star by them. This one and this one. These are the two main ones. But there are two other ways it could happen. If we are able to decrease the variability of our parameter, well, if we were able to do that, this would get skinnier. So therefore, now the power is everything that's in the blue, which is more than we had in the yellow. So we would be increasing that. Another way to, yes. And then the other one is to, if you're testing against a lesser null hypothesis. So if we had been testing 0.45 instead of 0.5, well, then this whole orange or green curve that I had would shift over to the left by 5%, which would increase that power as well. The line has shifted to the left. All right. That hopefully gives you some idea of power. Have a great day.